Good day, sir. Good day, everyone. My name is Ryan El Montejo, and today I'm gonna be discussing the 7 data warehouse physical design steps. So the first step is develop standards. Many companies invest a lot of time and money to prescribe standards for information systems. Building a data warehouse by following established standards will help your organization achieve a competitive advantage and lead to quicker development cycles. In a data warehouse environment, the scope of the standards expands to include additional areas. Standards ensures consistency across the various areas. So the next step is create aggregate plan. Aggregate planning helps achieve balance between operational goal, financial goal, and overall strategic objective of the organization. The goal of the aggregate planning is to minimize operating costs by matching production demand with production capacity. So the third step is determine a data partitioning scheme. Partitioning is the database process where very large tables are divided into multiple smaller parts. The main goal of the partitioning is to aid in maintenance of large tables and to reduce the overall response time to read and load data for particular SQL operations. The fourth step is establish clustering options. This technique involves placing and managing related units of data to be retrieved together in a single input operation. You need to establish the proper clustering options before completing the physical model. So the fifth step is prepare an indexing strategy. Indexing is a passive investment strategy where you construct a portfolio. The main purpose of the indexing is to facilitate filing. Indexing provides a reference list of files by name, subject, and date. The needed files can be quickly identified for proper filing of documents. So the sixth step is assign storage structures. Your storage assignment plan must include other types of storage such as the temporary data, extracted files, the staging area, and any storage needed for front-end applications. Let the plan include all the types of storage structures in the various storage areas. So the seventh step, or the last step, is the complete physical model. This final step reviews and confirms the completion of the prior activities and tasks. By the time you reach this step, you have the standards for naming database objects. So the next question is optimizing physical storage, or what is optimizing physical storage? It is a broad concept that works across all the technological and management layers of storage management to ensure existing storage resources are working in an efficient and cost-effective way. Indexing purpose and process. Indexing are used to quickly locate data without having to search every row in database table every time a database table is accessed. Indexing process at 4 stages, namely content specification, tokenization of documents, processing of document terms, and index building. Performance and enhancement techniques. So there are 7 performance and enhancement techniques. First is data partitioning. It is a technique of distributing data across multiple tables, disks, or sites in order to improve and increase database manageability. So the next one is data clustering. It is a task of dividing the population or data points into a number of groups. In a simple word, the aim is to segregate groups with similar traits and assign them into clusters. So next is parallel processing. It is a method in computing in which separate parts of an overall complex task are broken up and run simultaneously on multiple CPUs. Next is summary levels. If the users frequently request weekly sales information, then consider keeping another summary at the weekly level. Next one is referential integrity checks. Referential integrity refers to the relationship between tables because table in a database must have primary key. So the next one is initialization parameters. Parameters that affect system performance involve cursor sharing, the policy that determines work area size. So the next one is data arrays. Data arrays or arrays used to represent sensor simulation, image, or statistics data. So question number 3 is major data warehouse deployment activities with explanation for each. So there are 6 major data warehouse deployment activities. The first one is complete user acceptance. It is the one of the last stage of the software development lifecycle. It is conducted on a product by the end users of the product for approval for production release. The next one is perform initial loads. It is used to bring data into the data warehouse. So the third one is get users desktop ready. You need to prepare and arrange everything, the desktop of the user. So the fourth one is complete initial user training. Train the users on data warehouse concepts, relevant content, and data access tools. Initial user support. Set up support to assist the users in basic usage, answer questions, and hold hands. Deploy in stages. Divide the deployment into manageable stages in agreement with users. So number 4 question is data warehouse security. What is data warehouse security? A data warehouse is a veritable goldmine of information. All of the organization's critical information is readily available in format that is easy to retrieve and use. Security provisions govern a smaller segment of the corporate data, but data warehouse security extends to a very large portions of the enterprise data. Data warehouse security entails taking necessary steps to protect information so that only authorized personnel can access it. Data warehouse security should involve the following: strict user access control so that users of the warehouse can only access data that they need to do for their jobs. So backup and recovery. The backups will have to contend with the loads for the system time. Recovery is when a system crash, you will have the recovery options or the recovery process in the data warehouse. Backup and recovery describes the process of creating and storing copies of data that can be used to protect organization against the data loss. Recovery from a backup typically involves restoring the data to the original location or to an alternate location where it can be used in a place of the lost or damaged data. A data warehouse is a complex system and it contains a huge volume of data. Therefore, it is important to back up all the data so that it becomes available for recovery in future as per requirements. Data warehouse recovery is not any different from an OLTP system. However, a data warehouse may not require all of the data to be recovered from a backup or for a complete failure, restoring the entire database before user access can commence. So number 5 question is monitoring the data warehouse. When we implement an OLTP system, we do not stop with the deployment. Monitoring an OLTP system dwindles in a comparison with the monitoring activity in a data warehouse environment. The results of monitoring give us the data needed to plan for growth and to improve performance. The data warehouse monitor looks at what queries are being given to the system. Based on the queries, the systems can determine what data is being looked at. The monitor needs to present a complete picture of the access of the data. So as you can see in the picture, this presents the data warehouse monitoring activity and its usefulness. As you can observe, the statistics serve as the lifeblood of the monitoring activity that leads to growth, planning, fine-tuning of the data warehouse. Managing the data warehouse. The management data warehouse is a relation database that contains the data that is collected from a server that is a data collection target. This data is used to generate the reports for the system data collection sets and can also be used to create custom reports. So in managing the data warehouse management is concerned with two principal functions: the maintenance management and the change management. So in maintenance management, the data warehouse administrative team must keep all the functions going in the best possible manner. In change management, as new versions of the warehouse are deployed, as new releases of the tools become available, as improvements automation takes place in the ETL functions, The administrative team's focus includes the enhancement and revisions. In this section, let us consider a few important aspects of data warehouse management. Post-deployment administration covers the following areas: performance monitoring and fine-tuning, data growth management, storage management, network management, ETL management, management of future data mart release, enhancements to information delivery, security administration, backup and recovery, management, web technology administration, platform upgrades, ongoing training, and user support. Your data warehouse deployment platform includes the infrastructure, the data transport component, and user information delivery, data storage, metadata, the database components, and the OLAP system components. More often, a data warehouse is a comprehensive, cross-platform environment. The components follows a path of dependency, starting with a computer hardware at the bottom, followed by the operating system, communication system, the databases, GUIs, and then the application support software. As the time goes on, upgrades to the components are announced by the vendors. After the initial rollout, have a proper plan for applying the new releases of the platform components. As you have probably experienced with the OLTP systems, upgrades cause potentially serious interruption and abnormal work unless they are properly managed. Good planning minimizes the disruption. So monitor data warehouse users. Identify which users access the data warehouse frequently and which users don't. Monitoring users' usage helps identify heavy users of data warehouse and allows the data warehouse to support staff to provide additional support. The main purpose of a data warehouse is to be organized large amount of stable data to be easily retrieved and analyzed. So when setting up, care must be taken to ensure the data is rapidly accessible and easily analyzed. One way of designing the system is with the use of dimensional modeling, which allows large volumes of data to be efficiently queried and examined. Since much of the data in warehouses is stable, that is unchanging, there is hardly a need for repetitive backup methods. Also, once new data is loaded, it can be updated and backed up right away by the way of, in some cases, the data preparation database, so it becomes available for easy access. So management of data warehouse is a day-by-day management of a data warehouse that is ensure the information and is available and effectively backed up and secure. Like any other program, data warehouse can be used to design, create, and implement, so special measures should be in place to ensure the information is not lost. The data integration and ETL tool is mainly used for data warehouse creation and building data mart architectures. A component of the Business Objects Business Intelligence suite, called Data Integrator, provides a user with the opportunity of extraction and integration of data for analysis and reporting, as well as transforming and loading batch data.